Okay, question 4. The sum of the first term and the second term of a geometric series, so t1 and t2, is equal to two times then, the sum of the second term and the third term. So t2 plus t3, the sum of the second and third term. So the first two terms is equal to twice the sum of the next two terms, or the second and third term. Okay, so find the common ratio given that it's positive. Let's go for it. So T1 will be A, T2 will be AR, yeah? 2 times, well T2 we know is AR, and T3 is AR squared, yeah? We put 3 in there, you get AR squared. So first of all, what you could do is, well, shall we times through by that 2 there, just so it's clear. We've got 2AR there plus 2AR squared. You might notice here straight away now that every term has got an A in it. So we could divide by A, okay, straight away. You don't have to, but that's one approach. So A divided by A here is 1. Okay, so you've got to divide that by A, and you do get 1. Divide that by A, well, the A's cancel, so you get R. Okay, one good way is just to write this here, divide by A, divide by A, divide by A, divide by A, and you can see then they cancel, yeah? Okay, they cancel here, but you get 1, yeah? Because something divided by itself is 1. A divided by A is 1. Here you get R, here you get 2R, and here you get 2R squared, okay? So if we then get everything to the right-hand side, so I have 0 here, 2R plus 2R squared, take away 1, take away R. You end up having then, you notice a quadratic, so 2R squared plus R, take away 1. Okay, so quadratic there, simplified, equals to 0. You might prefer to write it like this then, so you've got the 0 here. Okay, so this then is straightforward quadratic to factorize, so whichever method you use, okay, you eventually get to this situation whereby you've got that there. So 2R minus 1 and R plus 1. Okay, that multiplies out to give this here. Okay, so then either 2R minus 1 is 0 or R plus 1 is 0. So R then will equal to a half, or R will equal to negative 1. Okay, in the question it says given that the ratio is positive, so given R is positive, R has got to equal to 1/2. Okay. So in part 2 then it says the sum to infinity of the series is 12. Find correct to 2 decimal places the sum of the first 8 terms of the series. Well, why have they told us this in part 2? Why have they told us the sum to infinity is 12? And you've got to ask yourself what information is given there by that. Well, how is it going to help us move forward with this? Well, of course, we want to work out the sum of the first 8 terms, but if you think about it, to work out the sum of 8 terms, we need R, but we also need A, don't we? And we're not given A, and there's no way of working it out in the first part, so this will help us, because if you use the formula A over 1 minus R, okay, well, knowing now that R is a half, you get A over 1 minus a half is equal to 12. So this will be A over a half is equal to 12, which implies then A has got to equal to 6. Okay, so once you've got that then, to get S8, well, we use the sum formula, okay, which is this, which is given to us in the formula booklet. So sum 8 is 6 then, 1 minus R, which is half. Now, to help you here, to write this a bit better on your calculator, put R as a half, but put it as a decimal, because it's easier to write here when it comes to powers, yeah? Okay, so do that, because it's going to save you a little bit of work. So on my calculator, we get, what did it ask for? 2 decimal places, 11.95 I've got there. Okay.